Hi students, in this session we will discuss more about impact analysis. Before that, let me remind you that impact analysis is one of the major steps involved in EIA procedure. Hope you all studied EIA procedure in detail. So, when we propose a project, the EIA procedure start with identification of the proposal, and after that the screening process is taken. By screening, we will let know that the proposed project needs EIA or not. The output of screening is initial environmental examination. So if EIA is required, we will do scoping, where major concerns and assessment methods are being identified. Then we will do impact analysis, and after that mitigation and impact management, and then to EIA report. By drafting an EIA report, we will review it. So from scoping to review, the public involvement typically occurs here. And in review, after review, we will get a statement or a detailed report, and it is called environmental impact statement. And by looking into environmental impact statement, the decision makers will decide whether the proposed project need to be approved or not. If not approved, we can redesign it, we can improve the project proposal, and we will resubmit it. Or if approved, project proposal is approved, then we will implement the project, and even after implementation we will follow up, we will monitor the project. So this is a EIA procedure in brief. Okay, so as I already mentioned, the screening phase of an EIA determines whether or not an EIA is required for a particular proposal. The scoping identifies issues and concerns, decides the assessment method, identifies affected parties, and invites public participation for agreement on debatable issues. And the next stage of EIA process is when a detailed assessment is undertaken to forecast the characteristics of main potential impacts. So, impact analysis is technical heart of the EIA process. So, in this stage only, we will take into account some uh, technical part. Okay, from impact analysis is a somewhat technical. So, what is an impact? An impact or effect can be described as the change in an environmental parameter which results from a particular activity. So, the change is the difference between environmental parameter with project compared to that without project. It is predicted or measured over a specified period and within a defined area. The characteristics of environmental impacts vary. Typically, parameters to be taken into account in impact prediction and decision making include nature, whether it is positive, negative, direct or indirect, magnitude, whether it is severe or moderate or low, extent or location, timing, duration, whether it is short term or long term or continuous, whether it is the reversible or irreversible, significance in local area or regional or global. These are some typical parameters to be taken into account while impact prediction and decision making. So, impact analysis can be broken down into three overlapping phases. The first one is identification, that is, identifying more specifically the impacts to be investigated in detail. And then prediction, predicting the characteristics of main impacts. And evaluation, evaluating the significance of residual impacts that cannot be mitigated. So these are the three phases in impact analysis. So impact identification and prediction are undertaken against an environmental baseline. The collection of baseline information and the relevant biophysical and socioeconomic condition begins during screening and continues in scoping. Hope you all remember that. The collection of baseline conditions and of the proposed project starts from screening and continues in scoping. So additional baseline data will be needed to be collected and to establish reference points for impact identification and prediction. So by taking these additional baseline data, these requirements should be identified in terms of reference. So early in EIAs, EIA focused only or primarily on impacts on the natural or biophysical environment, such as the effects on air, water quality, etc. However, over time, increased consideration have been given to social, health, and economic impacts. This trend has been driven partly by public involvement in the EIA process. It is reflected by the involving definition of the term environment in EIA legislation, guidance and practice. So in many EIA systems, a broad definition of environment is adopted. This can include effects on human health and safety, flora, fauna, ecosystem and biological diversity, soil, water, air, climate and landscape, use of land, natural resource and raw materials, protected areas and designated sites of scientific heritage, recreation and assets, livelihood, lifestyles and well-being of those affected by the proposal. So this all comes under the definition of environment according to EIA in many EIA systems. So depending on the EIA system, some or all of these impacts may require analysis and evaluation. Often, however, health, social, and other non biophysical impacts are either not considered or inadequately addressed. We will come into the first phase of impact analysis, impact identification. A logical and systematic approach needed to be taken to impact identification. So the main aim is to take account of all the important environmental impacts or project impacts and interactions, making sure that indirect and cumulative effects, which may be potentially significant, are not omitted. Okay. So this process begins during screening and continues through scoping, as we already mentioned, which identifies the key issues, classify them into impact categories for the further studies. In the next phase, the likely impacts are analyzed in greater detail in accordance with the terms of reference specifically established for this purpose. So over time, a number of EIA methodologies or tools have been developed for the use in impact identification. The most common formal methods used for identification, impact identification, are checklist method, matrix, networks, overlay and geographic information system, expert system, and professional judgment. According to our syllabus of environmental impact assessment CE 482, you need to study only checklist matrices and overlays or in a deep manner. Anyway, we will look into all of these methods, impact identification methods. Okay, so uh, we will move to checklist. Okay, checklist. A comprehensive and user friendly checklist is an invaluable aid for several activities of an EIA, particularly scoping and defining the baseline studies. Thus, where the checklist is being used more. The checklist has been prepared for known specialists and enables much time consuming work to be carried out in advance of expert input. It includes extensive data collection sheets, and the collected data can then be used to answer a series of questions to identify major impacts and to identify shortages of data. So a matrix indicates which data are linked to which questions. Okay. So this checklist is repeated at different stages of an EIA with varying levels of details, and checklist can be uh, useful as an input to the matrices. Okay, that is one of the major advantages of checklist method, and it is also available as a Windows based software package. So this enables the rapid production of a report directly from the field study. That's all about checklist, and let's look matrices. So matrices. A matrix is a grid-like table that is used to identify the interaction between project activities, which are displayed along one axis, and environmental characteristics, which are displayed along the other axis. Entries are made in the cells to highlight impact severity, other feature related to nature of the impact. So it may be using some uh, numbers uh, to highlight the impact severity. Well-known example is the Leopold interaction matrix, that is a well-known example for matrices, and the potential impacts are marked with a diagonal line in appropriate cell, and a numerical value can be assigned to indicate their magnitude and importance. This is what I mentioned earlier. A numerical value can be assigned to indicate their magnitude and importance. So the greatest drawback of matrices are they can only effectively illustrate primary impacts. So we'll go to networks. uh, networks is used to illustrate how impacts are related and what are the consequences of impact. They are therefore particularly useful in identifying and depicting secondary impacts, so indirect or cumulative impacts. So more detailed networks are visually complicated, time consuming, and difficult to produce unless a computer programming is used for the task. So that's about networks. So networks in impact identification is more useful for second depicting the secondary impacts. In matrices, it is for primary impacts. Okay. Then comes the overlay analysis. So overlays can be used to map impacts spatially and display them pictorially. So technique for illustrating the geographical extent of different environmental impact is called overlay analysis. Okay. This approach is useful for comparing site and planning alternatives for routing linear developments to avoid environmental sensitive areas, and for landscape and habitat zoning at regional levels. So Each overlay is a map of a single impact. Okay, a modern vision of overlay method is computer-based geographical information system, that is GIS. Uh, a GIS stores, retrieves, manipulates, and display environmental data in spatial format. So, overlay analysis overall illustrate or uh, map impacts spatially and display them pictorially. Okay, the use of GIS a lot EIA purposes is not as widespread as commonly imagined. Okay, the main drawbacks are lack of appropriate data and the expense of creating a usable system. So that's all about overlay analysis and GIS, geographical information system. And the other two methods are expert system and professional judgment for impact identification. Expert system, expert or knowledge based systems are used to assist diagnosis, problem solving, and decision making. Like GIS system, expert systems are an information intensive, high investment method of analysis. And expert system also can be updated by building in experience gained over time. And about professional judgment, expert opinion and professional judgment can be focused by use of interactive methods such as Delphi technique and science workshops to identify impacts, model cause effect relationship, and establish impact hypothesis. So expert system and professional judgments are also a part of are methods of impact identification, which are more information intensive one. Okay, so these are the methods of impact identification. And now let us just check the advantages of these methods. Checklist, it is easy to understand and use, and good for site selection and priority setting. And while coming to the matrix, it is all about link action to impact. Networks, useful in simplified form for checking for second order impacts. While coming to its overlay, it is focus and display spatial impacts. And GIS and computer experts system, good for experimenting. And some of the disadvantages for the checklist, um, do not distinguish between direct and indirect impact in checklist. Checklist is mostly done in during scoping, screening and scoping time. Okay, and do not link action and impacts in checklist. In matrices, it is difficult to distinguish the direct and indirect impact. In networks, can become very complex if used beyond simplified version. And for overlay analysis, the disadvantage is that poorly suited to address impact duration. And about GIS or computer expert systems, often complex and expensive is these methods. So this is a brief about all the impact identification methods usually used. And now uh, let us discuss about impact prediction, the second stage. Identification, the first phase was identification. We have already discussed about identification. Now let's go to impact analysis or impact prediction. So impact prediction, once all the important impacts have been identified, their potential size and characteristics can be predicted. So impact prediction or forecasting is a technical exercise. So it utilizes physical, biological, socioeconomic, and cultural data to estimate the likely characteristics and parameters of impact. Examples are magnitude, spatial occurrence, etc. A range of methods and techniques may be employed. These can be continuum from simple methods for impact identification, as we discussed earlier, to advanced method, often involving the applications of mathematical model. Okay, and in many cases, this work will need to be carried out by specialists in disciplines involved or in the applications of models and techniques. So, where possible, impact should be predicted quantitatively. This makes comparison among alternatives with the baseline conditions easier and facilitates impact monitoring and auditing later in the EIA process. If quantification is difficult, then it is important to use methods that allow the impacts to be estimated and compared systematically. Several major options are likely to have proposed either at scoping stage or before, and each options may require separate predictions studies. We already mentioned about that. So from screening through scoping, we are doing the impact prediction or impact analysis in a way. So we are going to what all are the impacts from scoping about the proposed project. Okay, so several major options are likely to have been proposed. Um, so realistic and affordable mitigating measures cannot be proposed without the first estimating the scope of impacts, which should be in monetary terms wherever possible. So it then becomes important to quantify the impact of the suggested improvements by further prediction work. Clearly, options need to be discarded as soon as their unsuitability can be proved or alternative shown to the superior in environmental or economic terms or both. Okay, so an important outcome of this stage will be a recommendation for mitigation measures. In this impact prediction also, it is important that to test a without project scenario. So comparison with the project and without project. Okay, so an important outcome is that recommendation for the mitigation measures. Uh, this would be contained in EIS. Clearly, the aim will be to introduce measures which minimizes any identified adverse impact and enhance the positive impact. So formal and informal communication links need to be established with teams carrying feasibility studies, and so their work can take proposals into account. By the time prediction and mitigations are undertaken, the project preparation will be advanced and a decision will most likely have been made to proceed with the project. Uh, Major changes could be disruptive to project processing and only accepted if predictions show that impact will be considerably worse than originally identified at scoping stage. So while doing scoping stage, we will have in mind about what all are the impacts and how it is. So after impact prediction or analysis, the major changes will be more noted about the project proposed project and only after accepted if this prediction shows that impact will be considerably worse than the originally identified at that stage. Okay, so two important models of impact prediction are one is mathematical model and other one is mass balance model. The mathematical model, the cause and effect relationship are expressed in the form of flow chart or mathematical function. As a mathematical function, if we can express the cause and effect relationship, then it's called mathematical model. And when this is usually adopted where physical changes are involved, it is called mass balance model. By changing the or by balancing the outputs. um, Here all inputs are balanced by the outputs. Okay, so by inputs, by changing the small changes in outputs, we'll manage the inputs. That is called mass balance model. Okay, so there are two type of important models: mathematical model and mass balance model. Let's go to uh, impact evaluation. Once the impacts have been analyzed, they are evaluated to determine the significance. A systematic process should be followed in evaluating significance, distinguish between as predicted and residual impact. Okay, so impact evaluation is a formal stage at which the test of significance is made. Okay, step 1 involves evaluating the significance of as predicted impacts to define the requirements for mitigation and other remedial actions. The steps 2 involves evaluating the significance of residual impacts, that is after mitigation measures are taken into account. So this test is critical measure of whether or not a proposal is likely to cause significant impact. Okay. Impact evaluation often serve as a accountability purpose to determine if and how well a program worked. This is a purpose of uh, impact evaluation. Impact evaluation can also help answer program design questions to determine which among several alternatives is most effective approach. These are some of the purpose of impact evaluation. And in impact evaluation, firstly, a technical judgment must be made of the extent to which mitigation will reduce as predicted impact. Secondly, a subjective value must be placed on the significance of residual impact using criteria and test described, already described. Okay, and finally, the attribution of the significance usually will influence final approval and condition settings. Okay, this is all about impact analysis. So impact analysis consists of three steps: identification, three phases: identification, prediction, and evaluation. Hope you all understand what is impact analysis stage and how impact analysis is working. Okay, um, so students, study well. This is all about your sixth module. Read some case studies of EIA. You will understand how to write the case studies of EIA, and study the EIA procedure very well, and these techniques to identify the impact analysis is also important. Thank you.